I'll tell you. When you read, you won't understand anything. I'll tell you what it means. Look at this. We have a Young's experimental setup. All right. Young's experimental setup. Okay. They say distance between the slits. So that means there must be slits. That means it must be interference. Correct. Correct. Then what? You know, I'll tell you what they mean. This is the central band, central maximum. All right. Central maximum. Listen to me, please. Central maximum. And then I take some point. I just draw one line here. Look at this. I just draw one line here. I'll just draw another line here. I take some random point, P. Okay. And I can call this distance and call this distance as hypotenuse of two triangles, right? Correct. So I'm going to do the condition for minimum here. Which minimum? Can you read the last sentence? Can you read the last sentence? First minimum on the screen for such a distance of, I call it x for the time being x. Okay. Later on I put it as d. X equal to d. Okay. I repeat one more time. I will illustrate the question one more time. See this? You know, I will draw it in a better way. Look at this. So let's draw the figure together. Draw the figure. Just draw the figure. I will interpret that. All right. So this is an interference setup. All right. How do I know it is not diffraction? Instead, it is interference. Because they say distance between the slits. No. You hear me?
It's given.
Oh, it's given. All right. It's given, right? Okay, fine, fine. Yeah, post-slip interference. Yes. So here it is. The screen. All right. And then right in the middle, we have a point. That point can be called O. All right. From O, at a distance of x, you take a point. Okay. Then just complete a triangle there. Complete a triangle there. Complete another one here as well. Okay. I call this distance S1, this distance S2, location S1 and S2, the slits. In short, I'll tell you what the question means is to get the condition for minimum at this point. I want this point to be what? This point to be, I want this point to be first minimum, right? First minimum. I want that point to be first minimum. I'll tell you the condition now. This distance, you know, it is capital D. Watch me doing this, don't do it until I see. All right. Okay. Now, what is this distance of screen from slits? That is capital D is equal to how much? Half of smaller d, right? Given capital D is equal to half of smaller d. Correct. Okay. So look at this. Can you tell me what this distance is? This distance is actually half of smaller d, right? This is how much? This is in fact smaller d, isn't it? Isn't it? Look at me, please. This is smaller d, isn't it? So in that case, this will be half of d, right? This also will be half of d, right? But half of d is what? Capital D. Half of d is what? Capital D. Am I correct?
So complete x minus o.
X minus?
O.
Yeah, x minus, not o is a point, right? So that distance, x minus d, that's what I'm going to take, that distance, okay? Right. So I repeat one more time, look at this. The slit separation is how much? Smaller d. Slit separation is smaller d. Listen to me, please. Smaller d. This is smaller d means this is also smaller d. So this will be half of it, right? Half smaller d. What is half smaller d? Capital D. Half smaller d, capital D. Right? Because I need this distance now. What is that distance? This minus this, right? Correct. I'll also need this distance. What is that? This distance plus this distance. Correct. Correct. I'm going to find, I call this point P. I'm going to find the path difference now. Path difference. What is path difference? I can call the path difference as S2P minus S1P. S2P is first path, S1P is the second path. Correct? How to get the path difference? This is you can apply Pythagoras theorem, right? Pythagoras theorem, right? I'll find them first. I'll find S2P first. Listen to me. S2P. Can you tell me what S2P is from the figure? S2P. S2P is hypotenuse. Base square. Base square. What is base square? D square plus altitude square. This much is x. This much is d. Altogether, x plus d the whole square. Am I correct? Under root. Okay. No? I'll take a moment. I'm finding S2P first. What is S2P? In this triangle, you apply Pythagoras theorem. Alright. In this triangle, you apply Pythagoras, bigger triangle, okay? I may call it S2OP. S2OP. Oh, sorry, S2 this P. S2 into BP. I call this B, this A. S2BP. Alright. Pythagoras theorem says what? It's very simple. Just application of Pythagoras theorem. Hypotenuse is equal to root of, tell me what? Root of base square. Base is d, right? D square plus altitude square. Altitude is how much? This is x, this is d. Altogether, x plus d the whole square. X plus capital D the whole square. Isn't it? X plus capital D the whole square. Okay. Similar way, what is S1P from the other triangle? Can you do the S1P? D square plus, this is how much? This much is x, this much is d. So this is how much? X minus d. So d square plus x minus capital D the whole square. Did you understand this? All of you got until here, tell me please. So I just assume that this point is first minimum. So I'm just finding this distance S2P, this distance S1P, alright. So I can find S2P minus S1P. S2P minus S1P. What is it now? Root of, tell me, root of d square plus x minus d the whole square minus, tell me what? Minus root of d square plus x minus d the whole square.
First one is x plus d.
X plus d the whole square minus x minus d the whole square. This is path reference, right? Path number 1 minus path number 2 is called path reference. So I put this condition, the path reference, d square plus x plus d the whole square minus root of d square plus x minus d the whole square to lambda by 2. First minimum is what? 2n minus 1 into lambda by 2, right? Originally it is 2n plus 1 to lambda by 2, right? 2n plus path reference equal to 2n plus 1 to lambda by 2. Put the first minimum. Oh, sorry. I put 2n minus, we took 2n minus 1 all along, right? Condition for minimum is 2n minus 1 lambda by 2. Put n is equal to 1, 2 into 1, 2. 2 minus 1, 1, lambda by 2, right? I am putting the condition of minimum as lambda by 2. Now I solve this, it's finished. How to solve it? I can put that condition. They have given that x is equal to capital D. This x is given as capital D in the question. They are asking you to find the condition for minimum at what? Can you read the last part? Minimum at a distance d from the center O. At a distance d from the center O. So I took it as x. They say it is capital D. So here, right here, I'm going to put capital D. What do I get? This is d square plus d plus d, 2d, right? 2d the whole square is 4d square minus, this is d minus d, 0. This is d, right? X is d, d minus d is 0. Root of d square will be d, right? It's equal to lambda by 2. D square plus 4d square, 5d square. Take the square root of it, root 5d minus d is equal to lambda by 2. From which you can compute. D is equal to lambda by 2 in the root of 5 minus 1. Got it? That is a condition for. It's a standard question, but it's very advanced questions. It was given in a sample paper. That's why I thought of doing it. Okay. It would come as a remark question, but this if you use the method, you can, any condition given, you can solve it now. Alright. First you have to apply Pythagoras theorem to first triangle, then apply Pythagoras theorem to second triangle, then take the difference, then put that condition is equal to minimum. Alright, if they say maximum, put maximum's condition. Understood? If they say first maximum, put 1 lambda. Second maximum, you put 2 lambda. Third maximum, you put 3 lambda. Because condition for maximum is n lambda. Correct? I'll do it again. So let's do it together, right? Start writing from the beginning, then I'll tell you what I. So first of all, you draw the figure, okay? Draw the figure as such. All these things are to be drawn. capital letter D. This distance is capital letter D. Okay. All right. So I have a YDSC setup. I have a YDSC setup. YDSC means what? Young's double slit experiment. Okay. The two slits here, they have a separation of small letter d. Correct? Correct. And then you take some random point over here, which is called P. Where is that point? That point is located at a distance of small x. But in the question, they have called it by the name capital D. That location is capital D. I'll use that information later only. I'll proceed for the time being. I'll proceed with x. Do you understand? I'll proceed with x. So that is my point. Now tell me, what are the distances? Look at me, please. This distance. Look at this distance. Can you tell me what this distance is? This distance is called small letter d, right? Correct. If this is small letter d, look at my fingers. Look at my fingers. If this is small letter d, this is also small letter d. Correct. Correct. Half of it is half d. Half d. Half d. What is half d? Capital D, right? So I write this distance as capital letter D. And this distance also as capital letter D. Got it until here, everyone? X is equal to capital letter D is given. Okay. Now, let us apply Pythagoras theorem. Okay? What is Pythagoras theorem? Hypotenuse is equal to root of base square plus altitude square. Look at this big triangle, S2P, okay? So let's write S2P first. What is S2P? S2P is equal to root of, okay? What is S2P? Look at this bigger triangle. Hypotenuse is equal to root of base square, D square plus altitude square. Altitude is x plus d. Correct. X plus d. I took it x because that is general now. You can apply it to any condition. X plus d the whole square. Correct. Now, similar way, in the other triangle, find S1P. Smaller triangle, find S1P. What is S1P? This is hypotenuse again, root of base square. This is base square, right? Look at me, this is base square, okay? That's also d square plus altitude. This is altitude. This much is x, this much is d. So that must be x minus d the whole square. Equation 1 and equation 2. Okay. Therefore, path difference. Now that I got path difference delta. Path difference delta is equal to what? How to get path difference delta? Path difference delta is equal to, okay. Therefore, path difference delta is equal to S2P minus S1. Paths are there, no? Correct. So path difference S2P. What is S2P? Root of d square plus x minus d. Oh, x plus d the whole square minus root of d square plus x minus d the whole square. This is path difference, right? For first minimum, we can call it equation number 3. For first minimum, they are saying that it is first minimum, right? First minimum. Path difference should be lambda by 2. What do you know? 2n minus 1 into lambda by 2, right? 2n path difference is 2n minus 1 into lambda by 2. Put n value 1. 2 into 1, 2 minus 1, 1 lambda by 2, right? So 2n minus 1 into lambda by 2. Now you can equate them. Put this as equation number 4. Now compare those equations and solve it. I'm going to substitute now. Tell me, root of, I just compare those equations, okay? D square plus x is also substituted as what? I'm going to substitute for x value. X is d, right? D square plus what? d square plus d plus d, d plus d the whole square minus root of d square plus minus d the whole square should be equal to lambda by 2. You understand? I just substituted for x. Nothing. In this equation, I just substituted for x. Look at the yellow one. Look at the yellow one. I just put this yellow one. X equal to d. Correct. Finish it off now. That's it. Finished. So this becomes what? Root of d square plus d plus d 2d. 2d the whole square is 4d square minus. This will be d minus d 0. Root of d square is equal to lambda by 2. 1d square plus 4d square, root of 5d square minus root d square is equal to lambda by 2. This is root 5d minus d is equal to lambda by 2. Or if I take d common, root 5 minus 1 is equal to lambda by 2. Or d is equal to lambda by 2 into root 5 minus 1.